All right, hello there. This is Jesse Johnson from Tutoring with a Twist, and I just wanted to make a quick video regarding fractions. I've got a lot of students who are in middle school or high school or even afterwards who've seen fractions and studied fractions when they were younger, but maybe are not so comfortable with them anymore. And that's fine. So I wanted to make a refresher video for fractions, right? They're not necessarily something that will teach them to you if you're encountering this for the first time, but something that will do a good enough job at getting you back up to speed and hopefully make you feel comfortable enough with them. Because hopefully by the end of this, I'll be able to convince you that they're very good and worthwhile, and it's not necessarily the best idea in the world to just convert them to decimals all the time in every situation. So to start with, we'll go to the basics and work our way up. Let's say I've got a pizza or a pie or whatever you like, and I've divided it into three equal-sized sections, right? We'll call these thirds, right? Because each one is just 1/3 of the whole pizza. And I'll shade one of them in, all right? That's me saying that I've eaten this third there. So to write this down, I'll put a 3 on the bottom of the line, right? Because I've cut the pizza into 3 pieces, and a 1 on the top. No, that might be fairly obvious, but bear with me. We could also, if we wanted to, cut this pizza up a little bit more, right? For instance, if I wanted to, I could cut up each slice like this, right? I'll cut the pizza up twice as much as I did before. And looking at what we have now, well, that would be, let's see, I've eaten 2 slices, and there are 6 slices in the pizza in total now. So this is 2/6, right? And now comparing that to 1/3, we'll see that these are actually equivalent fractions, right? And how do I know that? Well, because I didn't actually change the amount of pizza that I ate. All I did was I changed the way it was cut, right? And for that matter, you could take it a step farther. Maybe you divide the pizza up like this so that you've all those original slices have been cut up into 3 pieces. All right, what have I done now? Well, now I've got 3 slices that I've eaten, but the entire pizza has been cut up into 9 pieces, right? As I'm sure you can recognize, you can keep up with this pattern. You'd eventually have 4/12, or let's say 5/15, for instance. Oops, 15, right? And I'm going to say that these are all equivalent fractions, right? So one number might be represented a whole bunch of different ways in fractions. And how can we tell that fraction is equivalent? Well, you'll notice that to get to this one to that one, I had to multiply the top and the bottom by the same number, right? So I've gone from 1/3 to 2/6, right? By multiplying 1 by 2 and 3 by 2, right? Similarly, I could say multiply them both by 5 to get 5/15, or multiply them both by, I don't know, whatever I want to do, 17, let's say, to get 17 over whatever 17 by 3 is, right? So we can recognize that these are equivalent fractions. So this will lead to an exercise that we'll want to do, which is going to be reducing fractions. So for instance, let's say you're out there in the wild and you see 2/6 pop up, right? Hopefully you're able to say, aha, I recognize this as one of those more complicated versions of that 1/3 that I saw earlier, right? And how do I know that? Well, I was able to get 2/6 by multiplying the top and bottom of 1/3 to get something that was equal to it. Well, if I wanted to, I could also undo that by dividing by 2, right? Rather than multiplying by 2 to get 2/6, I can divide by 2 to get 1/3, right? So if I divide the top and the bottom by the same number, no harm, no foul, I've gotten another number that is equal to it, right? Let's do another example just to make sure that you've got this, right? If I had something like, let's say, 2/8, aha, well, I could divide the top and the bottom by 2 and simplify this down to 1/4, right? Maybe another example. Let's go. How about 10/15, right? Well, I could, you'll notice that these are both divisible by 5. So we'll divide the top and the bottom both by 5 to get 2/3 as the simplest form of that one. And a couple of things that we might notice here. First of all, if you've got, say, something like anything over itself, let's say I've got 13 over 13. Well, what is this? Well, that's as though I had cut a pizza up into 13 slices and then eaten all 13. Well, that's just a whole pizza, right? So if we wanted to, we could divide the top and bottom of this, and we get 1, right? That's 1 whole pizza, right? We'll also notice that anything over itself, let's say I've got 4 over 1. Well, if I take a pizza and I cut it up into 1 slice per pizza, and I take 4 of those, well, that's the same thing as 4 pizzas. So anything over 1 is going to be itself. Anything over itself is going to be 1, right? So keep that in mind moving forward, and try to get, if it's possible, try to make sure that you can stay at least moderately comfortable with what we're calling improper fractions. Now, in elementary school, you probably touched on something like this, right? Let's say you've got something like 7 over 5, right? And they definitely wanted you to transform that and to say, well, I can take 5 out of 7, so that's 1, and then there would be 2 left over, so this is 1 and 2 over 5. Now this is nice, right? It's good in that it lets you know that 7 over 5 is, say, bigger than 1 but less than 2, right? But it's not good for more complex algebra, right? So we're going to say that we don't like these mixed numbers. We're letting them go, and they are hereforth forbidden, right? We're only going to be using these quote unquote improper fractions. We like those much, much, much better because it gives you a much better idea of what's going on. Oh, I get it. It's like I took a pizza, cut it up into 5 pieces, right? And I got 7 slices that are that big, right? Now, moving on, right? We might wonder what it's like to multiply fractions, right? Or even to multiply a fraction by a number that isn't a fraction. So let's say I go to a party, right? And I see 3 pizzas, right? All in a row. And let's say they're different types. So maybe I've got a cheese pizza, a pepperoni pizza, and a vegetarian pizza, for instance, right? And I want to varietize. I don't necessarily want to eat more than 3 slices or I'll get sick, but I want to have a little bit of each, right? So I'll eat 1 slice of the cheese. I'll have 1 slice of the pepperoni, and I'll finish it off with 1 slice of vegetarian. Now, how much pizza is this? You might be tempted to say something like 3 over 15. After all, earlier, if I was eating, say, 4 slices out of a pizza that was cut into 12ths, we said 4 over 12. So it stands to reason that if there's 15 slices of pizza, I'm having 3 of them. That is 3 over 15, right? Which is reasonable. You could reasonably say that I am eating 3/15 of the pizza overall, but it would not be reasonable to say that I'm having 3/15 of a pizza. Now, why is that? Well, for one thing, you could notice that this reduces down to 1 over 5. It'd be as though I ate just 1/5 of one pizza, which isn't what we're talking about at all. And, for another thing, if you were to write 3 over 15, well, this 15 sort of has the implication that it is a 1 over 15 slice of pizza. It's a entire pizza cut up into 15ths, right? And it's not that. It's pizza cut up into 5ths. So we'll get rid of this 3 over 15 idea. And let's see what else we can do. Right? Well, we could say this is 1/3, this is 1/3, this is 1/3. I'm eating all 3 of them. Did I say thirds? So sorry about that. Getting a little ahead of myself there. They're all 5ths, let's say. Right? And so I'm eating that one, and that one. I eat all 3. What do we call this? Well, if you really wanted to, oops, didn't mean to do that. You could imagine you're just eating all of those off of one pizza, and this is going to become 3 over 5, right? So if you're adding up these fractions that have the same base, it's very easy. You just add the numerators together, right? Another way that you might think about this is it's kind of as though I had multiplied my 1/5 by 3. So if you wanted to think about it like this is 1/5 times 3, right? And as we've shown, that's going to be equal to 3 over 5. And in general, in fact, if you multiply a fraction by some, regular integer, some regular number like that, that's just going to be the same as multiplying the numerator, multiplying the top part, by whatever integer it was that's doing the multiplication. So to give another example, let's say we've got something like 4 over 5 times 3, right? Well, that's easy. I'll multiply the 3 by the 4 to get 12. And importantly, the bottom's going to stay the same. If I multiply that 5 by 3, then that would give me something different. That would be the same thing as rewriting this as an equivalent fraction. We don't want to do that, so we'll just keep it as 5. Right? An important thing to keep in mind about fractions is that they are, in a very real sense, division in disguise. Right? So say, for instance, that I went to a party and there are 40 pizzas, right? There's a whole row of 40 pizzas, and I eat a fifth of each of them, right? Well, what would that be? That would be 40 pizzas. I'm eating a fifth of each, so every 5 pizzas that's laid out, I eat 1 pizza, right? Doing the math here, we'll see that you could describe this as 40 over 5, right? And that's going to be equal to what, 8? 8 whole pizzas, right? And we see that that's equivalent to 40 divided by 5, right? 40 divided by 5 also is 8, right? You can even see that if you look at this fraction symbol here, this division sign, right? We'll see that actually kind of looks a little bit like a fraction. It's kind of got that bar and the thing on top and the thing on bottom, right? So we have that multiplying fractions, or multiplying fractions by a regular number, is very, very easy, right? Looking forth, let's give this a shot. What if we wanted to multiply one fraction by another fraction, right? Well, we know that fractions are kind of the same thing as division. So really, what's this saying? This is 4 divided by 3 multiplied by 5 divided by 2. Well, the order of that doesn't matter too much, right? You can, dead mass, you can shift around the order of multiplication to division however you please. So if I wanted to, I could rewrite this as first 4 times 5 divided by 3 times 2, right? So multiplication of fractions is very, very, very easy, right? All I have to do is multiply the numerators, multiply the tops together, then multiply the denominators together, combine them. 4 times 5 is 20, 3 times 2 is 6. Ta-da! And if you like, you're free to simplify this. That's going to be 10 over 3, right? Once again, we're trying to get used to these improper fractions. There's nothing improper about them. Perfectly fine, right? Let's give another practice of this. Let's say we had 2 over 3 multiplied by 3 over 7, just say, for instance. Now we'll do our same thing before. 2 times 3 is going to be 6. 3 times 7, well, that is 21. We get 6 over 21. But hey, both of these are divisible by 3, so we can simplify this to 2 over 7. And isn't that a funny coincidence, right? This 2 over here, that 7 down there. Well, that kind of makes sense. If you want, you could imagine that you're cross-canceling. Maybe this is a little bit advanced, or maybe even a little bit unnecessary. But if you wanted to, you could say that this 3 here crosses out with that 3. They undo each other, right? Or at least they will once you multiply them together. So you can do what's called cross-canceling. Now, we've talked about how to multiply fractions. Surely, it doesn't seem that bad. Multiplying fractions is very tame. Surely dividing fractions must be at least a little bit more intimidating. And maybe it is, but let's think about this for a minute. Let's say we were to change this from 4 over 3 times 5 over 2 to 4 over 3 divided by 5 over 2. Right? Now, as we said, division and fractions are kind of two sides of the same coin, so we won't necessarily write out this division sign too much anymore now that we're in middle school or high school or college. But we can still think about it, certainly, and it's still a useful concept to have. What is 4 over 3 divided by 5 over 2? Well, this is 4 divided by 3 divided by 5 divided by 2. Well, so if we wanted to, we could say 4 over 3, the 5 is going to be on the bottom, right? Because that's what we're dividing by now. And the 2 likewise is going to switch. So this division of two fractions, all we had to do was take the second one, flip it upside down, and then we can multiply by that. Right? 4 over 3 divided by 5 over 2, that's equal to multiplying by the reciprocal. Right? 4 over 3 times 2 over 5, which for the record would be, let's see, 8 over 15, which is not simplified. And this is very interesting. We can use this to confirm a lot of things that we already knew, right? For instance, let's say we've got 1 over 3 multiplied by 4, right? Well, as we discussed, you could rewrite 4 as 4 over 1, right? Anything over 1 is just itself. So 1 over 3 times 4 over 1 is going to be 4 over 3. 4 times 1 over 3 times 1. Just like we expected. And for that matter, let's say we've got, I don't know, 7 divided by 2. Well, that's the same thing as 7 multiplied by that reciprocal, 1 over 2, because 2 is secretly 2 over 1, right? And of course, we already know what this is. This is 7 over 2. Another reason why we know that divisions and fractions are really exactly the same thing. So multiplying and dividing fractions is not so difficult, right? There's really not all that much to it. You just do it straight across. And this leads some people to say, oh, well, that's great news. So if I have something, let's say something like this, right? I can just do exactly what I expect. I can just go ahead and add the tops. I get 2, add the bottoms, I get 7. And hold on a minute here. That doesn't seem right to me. Right? If you don't believe me, that seems a little bit too small. 2 over 7, well, that's even less than 2 over 6, right? So 2 over 7 is less than 2 over 6, which is equal to 1/3. So if this is right, then that would mean that 1 over 4, when added to a third, makes a third less. Clearly, this is not the right thing to do here. So if you want, let's remember a few pages back when we were, dealing with those pizzas, right? We had 1 over 5 plus 1 over 5 plus 1 over 5, right? Well, this makes sense. A fifth plus a fifth plus a fifth, that's 3/5. It even makes sense in the English language that those things would be equal to each other, right? So going back over here, we know that this is wrong. So let's take another shot at it. Well, if only these were the same thing, by which I mean, if only these fractions had the same denominator, I could regard these as, equally sized slices of pizza, rather than one slice plus another slice, but they're different sizes. Well, the good news is, like we said, we can always turn fractions into another form by multiplying the top and the bottom, right? That does not change the value of the fraction overall. So 1/4, we'll multiply that top and bottom by 3 to get 3 over 12. And a third, multiply the top and the bottom by 4 to get 4 over 12. And now we're in business. 3 over 12 plus 4 over 12, 7 over 12, 7/12. Which should only, stand to reason. 3/12 plus 4/12 is 7/12. It's kind of like saying, I don't know, 3 apples plus 4 apples is 7 apples. Just instead of an apple, we have a, what we'll imagine as being a 1/12 slice of pizza. So let's do another example. How about, let's say 1 over 6 plus 2 over 9, for instance. Well, we can always just go ahead, if you don't know what to make as the new denominator of the new versions of these, you can always just multiply the denominators together. After all, that's bound to work. If you multiply the top and bottom of this by 9 and the top and bottom of this by 6, well, definitely their bottoms will be the same. So this is going to be 9 over 6 times 9 is 54. It's okay if the arithmetic comes to you a little bit slow. We've got calculators for that. It's nothing bad, right? Multiply the top and bottom of this. 2 times 6 is 12, and of course 9 times 6 is also 54. 9 plus 12, 21 over 54. Of course, we'll notice that this does in fact simplify. Right? Divide both top and bottom by 3. It's okay if the bottom doesn't necessarily look divisible by 3 to you. Just take my word for it when I say that it is. Right? 21 divided by 3 is 7. And 51 divided by 3 is 18. Now, some people will tell you, and they're right to say so, it's a reasonable thing to say, they'll tell you that you need to find the lowest common denominator, right? So for instance, in this one here, 1 over 6 plus 2 over 9, well, that could just as easily, rather than going, taking them both to 54ths, I could have multiplied this one by 3 to get 18ths, and this one by 2 to get 18ths, right? And they still would have added together just fine, right? I could have skipped a step. And if you like to do that, if that's something that makes sense to you and you like that, I'm definitely not going to stop you. But it's also not necessary. And if it's something that confuses you, you're welcome to skip over it. You'll just multiply the top and bottom by each of these by the other one's denominator, and then you can simplify at the end if you like. So let's give it one more shot. Let's say I'm just going to come up with 2 totally random fractions here. Let's say 1/5 plus, I don't know, 1/10, right? Well, if I wanted to, I could, put them both into tenths, right? There's no reason not to, and that would give me 2 over 10 plus 1 over 10, right? Which is 3/10. Or if you really just want sort of a formula to follow, let's multiply the top and bottom of each of these by the other one's denominator. This will become 10 over 50. This will become 5 over 50, right? Which is 15 over 50. The top and bottom are both divisible by 3. So I'll simplify to 3 over 10. Did I say they're both divisible by 3? I meant to say they're both divisible by 5. So there you have it, right? There is the general rules of multiplying, dividing, and adding fractions, right? If you have a fraction, you can multiply the top and bottom by whatever you want, right? And you won't change the value. If you want to multiply, you'll just multiply 2 fractions together straight across. To divide, you'll just flip whichever one you're dividing by and then multiply by normal. And to find their, add them together, that's just as easy as making sure that they have the same base, the same denominator, right? Now, why do I care so much? Right? Let's say, why do I think fractions are so neat? Why can't I just put everything in decimal? After all, I can put any fraction I want into my calculator. It'll be in decimal, and that'll be great. Well, for one thing, I'm kind of concerned about accuracy, right? Let's say that somebody asks you a math problem, and you don't know how accurate they need it to, right? Maybe they're building something and they only need things like rounded to the nearest foot, but maybe they need everything, rounded to the nearest 100th of a centimeter, right? So you want to be perfectly accurate with them. Well, if you have a fraction like 1 over 7, this is a great way to describe that number, right? If you wanted to describe that with your calculator, that would be, let me pull up my calculator and I'll find out, and you're welcome to follow along. 1 divided by 7 is equal to an infinitely repeating decimal, and it's an ugly one too. Looks like 0.1485, I'm just checking, 5714 ... It goes on forever, right? So here are your options when talking about 1/7. You can either write down this decimal forever, right? You could cut it off someplace and estimate. Probably the best thing to do is to put the bar over it and say that these 5 digits repeat forever. But wouldn't it be easier to just say, well, imagine I've got something and I cut it into sevenths and I take one of those 1/7 portions. Right? So that's one reason that we like fractions, is because they let you be very, very precise, very, very easily, without having to write down all these numbers and decimal points and all that. Right? The other reason is that, let's say I'm solving an equation, maybe I've got something like 1/7 times x equals 5. Right? Now, there's no reason for me to, not to. There's no reason for me not to say that 1/7 is that big, long, gross decimal, right? And then say, all right, well, now I'll divide both sides by that big, long, gross decimal and let the calculator take care of it. But wouldn't it be so much easier for me to say, aha, well, I know that if I multiply by 7, this will become 7/7, which is equal to 1, which will undo it. So if I want to solve this equation here, all I've got to do is multiply both sides by 7. Isn't that so much easier once you know what you're doing, at least? And the third reason, right? So there's reason number 2, is that if you had something like 7 times a 7th, you can easily see that that's going to cancel out, right? Whereas if you had, say, 7 times 0.1, what was that? 1428751 or whatever it was, right? It is absolutely not clear to me that these two things multiplied together are going to come out to 1. It's very clear to me in this case. The other reason, and this is maybe the biggest one of all, is that, like I said, we're going to start using fractions instead of division. And why not? They are the same thing after all, right? But that means that if you have a solid grasp of fractions, then you can use that to build a solid grasp of more complex things, of even more, more difficult math, right? So for instance, if we have x times y over 2y, well, we can tell that y is a factor of both, divide the top and bottom by y, and we'll get x over 2. And that's just one example. I'm sure in your classes, you'll probably see plenty and plenty and plenty of examples where a solid understanding of fractions is going to serve you well in talking about division between variables. In any case, that's all I really wanted to say. I think personally that is plenty on fractions, and if you understand and know everything that I've talked about in this past half hour, you are doing pretty well to understand what's going on in your algebra class or your pre-calculus class or whatever it is. So hopefully that was helpful for you. And maybe at some point later on, we'll do something like this again.